So how do we go about solving equations that have exponential functions or exponential expressions in them? That is, how do we solve equations where there are variables in the exponent? All right, well, there's a couple of different ways we can approach this. There's one where it's kind of the good situation, and there's one that's the not so good situation. Right, in this lecture, we're going to focus on the good situation. What I mean by that is a situation where the bases are the same. Right, because when the bases are the same, it's really pretty straightforward. The only way these two exponential expressions can be the same is if their exponents are the same. So do that. I'm going to set x equal to 2x plus 4. Solve this equation. Subtract 2x from both sides. Multiply both, or divide both sides by -1. X equals -4, and there's the answer. That's all there is to it. I say that's all there is to it. It never stays that straightforward, right? So let's look at another one here. Look at this thing. Right here, the bases are not the same. One is 4 and one is 8. But before you give up, say we can't do this yet, ask yourself, can you make them the same? Right? Because here I think I can. If I make 4 2 squared, and I make 8 2 cubed, now look at what happens. Now the bases are both 2. Right? I'm going to do a little exponent here. Right? I can multiply the exponents on the left, multiply the exponents on the right. Now the bases are the same. Right? So I'm going to set the exponents equal to each other and solve these equations. So I'm going to distribute. Get 2x minus 2 equals 3x plus 12. Subtract the 3x. Negative x minus 2 equals 12. Add the 2. Minus x equals 14. X is negative 14. There you go. There's your answer. Right, so sometimes we can kind of work it out. Right? Okay. So how about this one? Right? You can try this one on your own if you like. We can make those bases the same. It is possible. All right, so how am I going to do that? Well, the 8 is pretty straightforward. I'm going to make that 2 to the third to the x plus 1. Well, how about the right-hand side? Well, I know I need it to be a 2. Right? I know I need to have a 2 down here for the base. And if I make the exponent -2, that works. 2 to the -2nd, that's 1/4. And now I proceed just like we have before. Negative 2x equals 3 times x plus 1. Negative 2x equals 3x plus 3. Let's move the 3x over. Minus 5x equals 3. X is negative 3/5. And there you go. Now we're done. Right? It was possible here. You just might have to bring negative exponents into the mix. All right, so I've got one more here. Right? Let's try this one. The left side, 5 is prime. There's nothing I could do with that. So I'm going to leave the left side alone. The right side I can do something with. 25 is 5 squared. And now I can set the exponents equal. 2x plus 3 equals 2 times x plus 1. 2x plus 3 equals 2x plus 1. Subtract 2x, and I get 3 equals 1. Okay, variables all went away. And I'm sure this is not your first algebra class. You've seen this happen before. Sometimes all the variables get eliminated. And when that happens, you're going to do the same thing here as you did with all the other algebraic equations where you've seen this happen. 3 is not equal to 1. That is a false statement. That means this equation is never true. In other words, it has no solutions. And similarly, if it had come out to something like 3 equals 3, for example, something that is always true, then the solution would have been all real numbers. The exact same thing you saw happen in previous algebra classes working with just regular linear equations. Okay, so what's next? Well, we finally come to kind of the climax of this chapter, if you will. We're now ready to talk about what are called logarithmic equations, right? Logarithmic equations being the inverses of exponential equations.